In this video, we're going to use the AIMS eReefs Visualization Portal to try to answer the question, which direction does the flow of the flood plume from the Burnett River mainly flow? And this is really just an example of using the tool to address a particular question. The tool is not particularly designed to answer this specific question, but this was an example one to really show how you can use the tool to investigate various aspects of a given problem. Now, when you are trying to answer a question using this tool, you have to know a little bit about the models and what they show. There's two main models that we focus on. There's the hydrodynamic model, which really focuses on the movement of water. This shows things like temperature, salinity, ocean currents. And the biogeochemical model, which really tells you about what's in the water, the nutrients and sediments. In our case, the best model is really the hydrodynamic model because we're looking at the movement of a flood plume. The best variable to really look at this, the trace of the river plume, is the river tracer data, which is done in the model. Unfortunately, we don't have a visualization of that variable just yet. We're working on that as we speak. However, we can still address this question by looking at the salinity. Now, the salinity is the measure of how much fresh water is in the seawater, and that allows you to look at where the plumes are moving in the ocean. So we have two versions of the hydrodynamic model. The 1 kilometer model, which is your preferred model if you have a relatively short time frame. The 1 kilometer model started in 2015. The 4 kilometer model started in the end of 2010. So if you have a short time frame, it's best to use the 1 kilometer model because it's more detailed. The 4 kilometer model, however, gives you that longer time span. So in our case, we're going to use the longer time span of the GBR4 model. Now we're interested in the Burnett, which is down here, and so really we want to zoom into that particular region. Before we do that, a general overview of the tool. We have the visualization in the middle. There are various aggregation periods which we will use to find periods of interest. We have the ability to zoom in here and to adjust the time frames over here. And you can also look through some depth profiles if that's important for your question. In our case, we want to zoom in around the Burnett, and the best visualization is this one, as we can see the outflow from the Burnett River. The first question is, well, when did flooding occur from the Burnett over all the years? If we simply look through all the hourly data, it would take quite a long time to find the years where there was flooding. And so one technique we can use here is simply look at the yearly averages. And by that we can see whether there was any flooding at all in a given year. So here we can see in 2020, basically there was no flooding. There's no real fresh water. The lower the value here, the more fresh water there is. So as we go through the years, we can also see that 2019 there was no flooding. 2018, not a tiny bit in 2017. Tiny bit in 2016, tiny bit in 2015, none in 2014, a significant amount in 2013, not much in 2012, a fair amount in 2011 and 2010. So the next step is we want to refine that time frame to, well, which were the months that are important to look at. And we can see that flooding started to occur at the end of 2010, and then it continued into 2011. And in the 2013 year, it started, let's check the end of 2012. Okay, so there was nothing at the end of 2012. So it started in January 2013 and then proceeded into February. So they're the months that we should focus on looking at even higher resolution. So now we're going to look at the hourly data in those particular months and look at the direction of the plumes and what might have been causing those, and therefore get a sense of how consistent is this data with the 2 time points, because we've really only got 2 years, and so to know whether it's typical, we really need to have a better understanding of whether we're seeing anomalous years or whether that's a general principle. So first of all, we'll start off with 2011, actually 2010, and we can see that it's the start of December there was no flooding. Let's skip ahead a bit. Now we've got start of the flood. We can see that the wind is blowing south. It's pushing the plume southwards. Then as it moves north, it moves northwards. Quite strongly, in fact. It's only when the wind is actually really strong that it starts to go southward at all. Now when we look at 2011, we can see that trend basically continues on. We skip along. Now we're seeing additional water coming out of the Mary. And you see that the direction is really dominated by the flow, the direction of the wind, but it's also an interaction with the ocean current. And that's a little bit more obvious in 2013. So let's have a look at that in detail. So there's no flooding at the start of January. Okay, so here's about the start. Now we can see there's a very strong wind blowing south. The plume goes out and then it basically goes northward. There's still some residual left over here, but the majority of it moves north. And you can see that the ocean current here is actually more driving it northwards. We have a tidal signature going in and out. And we can see these trade winds blowing it north typically. So one last thing to look at in a little bit more detail is how much, if the wind happens to be blowing south, how far will the water penetrate into the bay? And we can see this as we step through these individual frames, where the wind is blowing south quite strongly. And as the plume comes out, it still doesn't go into this bay, right? You can see there's a little bit of current going south, but as those tides swing back and forth, there's more of a current which is drawing it out off the shelf and not into the bay. And so even when you get these periodic bursts of wind going south, I think we can say that it's typically not going to go into this bay in a big way. It's going to tend to prefer to go north. And just to look at that a little bit more, we can look at the monthly wind conditions, the direction of the wind, and look for the years when there was no flooding, but see whether the wind direction is somewhat consistent. So if we look at the monthly average wind for the other years, we can see here there's a slight northward direction to the wind in January and February. We can also see the ocean currents are pretty much static, and so they will not be driving the direction too much in that year. The wind direction is pretty similar for 2015, quite strong northward. In 2016, same pattern. The trade winds pick up in February. Same in 2017, trade winds not quite so strong. Same in 2018 and 19 and 20, although not as strong here. We can see that typically the wind is not going south, and even if it does, it doesn't tend to go into the bay. And so I think from looking at all that evidence, we can be pretty confident that typically when the plume occurs in these summer months, that the wind will tend to drive it northwards. So that's kind of been a bit of analysis that we've done using the existing visualizations. The tools themselves obviously are currently set up to be fairly generic in nature and allow you to answer a different variety of different questions. But by providing you with this context around a given question, then you can start to understand why the particular things happen, and therefore you can extrapolate whether they're typical or not. So even though we've only got 2 flooding years, by looking at the winds and currents in the other years, we can see that the direction of the plumes that they happened were actually quite typical because they're driven by the wind and the current. So hopefully you got something out of this tutorial, and it'll help you to answer some of the questions that you have.